Okay, so looking at part F, we are going to do the same thing here where we have the limit as x approaches 2 of f of g of x. And notice how here, this is basically a flip of part B. So now g of x is going to be my inside function and f is my outside function. So here, I want to look at 2, the limit as x approaches 2 of g of x. And notice once again, it's not continuous. Because it's not continuous, I'm going to break this apart and separate it in terms of my left-hand limit and my right-hand limit. So as we approach g of x for 2 from the left right here, you could see that I am approaching 1. And then we'll talk about where. And then same thing here for 2 to the right. I'm approaching -1. Now, whenever we're doing this, we also need to think about where we are approaching it. So is it above or is it below? So looking at 1 here, you could see that all my values, I am approaching it from below. So the values that we are approaching 1 are going to be below or less than 1. So your line's like kind of below. Same thing for 2 to the right. Notice how here my line's like above the limit. Since it's above, you know that it's going to be plus. So now I have the limit as u approaches 1 from the left of f of u, and then the limit as we approach as we approach -1 from the right of f of u, and then we're going to evaluate that. So once we do 1 from the left, we're going to get 2. As we... Oh, sorry. Why did I do that? 1 from the left, we're going to approach 1. Don't know why I said 2. And then as we approach -1 from the right, we are approaching 1. Since your limits are the same, we know that as the limit as x approaches 2 of f of g of x, we'll approach 1. Okay, so we're going to do the same things with d and e, except these aren't compositions of functions. These are going to be using our limit laws to figure out what's happening. So looking at, let's say, part E, where I have the limit as x approaches 2 of f of x plus g of x, we want to look at 2 in terms of both f of x and g of x. You'll notice that at 2 for both f of x and g of x, well, we have a jump discontinuity here and we have a jump discontinuity here. So we're going to make our little split for 2 from the left and 2 from the right. So now I have the limit as x approaches 2 from the left of f of x plus g of x. We're going to use our limit laws and break that apart. So now I have the limit as x approaches 2 from the left for f of x plus the limit as x approaches 2 from the left of g of x, and we're going to evaluate that. So the limit as x approaches 2 from the left of g of x will give us 2, and then g of x will give us 1. So 2 plus 1 will give us 3. Now I'm going to do the same thing for my right side of the limit, and hopefully we pray that it's going to be 3. If not, then it's going to tell us that the limit doesn't exist. So now I'm going to break this apart. And see what happens. Okay, so the limit as x approaches 2 from the right of f of x is going to be 4. And then same thing here, 2 from the right, it's going to be -1. So I'll have 4, -1, and that's 3. Since we have 3 and 3, we know that the limit as x approaches 2 of f of x plus g of x will be 3. Okay, so part D, same thing. We want to look at -1 and see if it's continuous at both f of x and g of x. Well, at -1 here for f of x, we have a jump. Same thing here, we have a jump. So we are going to break this up into our two limits. The limit as x approaches -1 from the left of f of x times g of x. And I'm going to write the limit using my limit laws so that it's quicker for me. Gonna do the same thing for -1 from the right. Okay, so let's look at -1 from the left for both f of x and g of x. Negative from the left will give me 0. -1 from the left will give me 0. Oh, nope, sorry. Not 0, 2. So 0 times 2 is 0. If I were to do the same thing for my right side of the limit, I have 1. And then my right side of the limit here is going to be 0. So now I have 1 and 0. That's going to be 0. Since both of them are 0, we know that the limit as x approaches -1 of f of x times g of x is 0. All right, I'm going to do one more example, and I'm going to do number 2 on the next page, where we have the limit as x approaches 2 from the left of g of 4 minus x. We're still going to be using what we did earlier, where we are going to find the limit of the inside function first. So I want to find the limit as x approaches 2 from the left of 4 minus x. Now, it's going to be very important to draw this out because we need to figure out if that limit is going to be above or below whenever we find a 2 from the left. Even though it's continuous, yes, we just need to figure out, is it going to be above or is it going to be below? Here's my little sketch of 4 minus x, and let's say that this is 2. And then we know that that's going to be 2. But, because 4 minus 2 is 2. But we need to figure out if I'm going 2 from the left, is it going to be above or is it going to be below? Notice how my line is above the limit that we're approaching, because remember, these values are going to be something like 2.01, 2.02, 2.03, and so forth. So I know that I'm approaching it from the right. Once I do that, I'm going to have the limit as u approaches 2 from the right of g of u, and finding g of u, wherever that graph is, and 2 from the right, I know that I am approaching 3. So the limit as x approaches 2 from the left of g of 4 minus x, not -3, would be +3. All right. These problems are going to be very similar to the problems that we had above. So either use your limit laws like 3 and 5 and maybe 7, or use compositions of functions for 1, 4, 8, and 6. For number 4 and for number 8, you're going to use what I did earlier with number 2 and maybe number 3 too, where you might need to draw out your inside function first and see what's happening there, and then evaluate. The key for this is going to be in the student notes folder, so make sure that you look at that in terms of this part of the lesson.